So the multivariable function x squared minus xy plus y squared minus y, and it's a 5-part question. We want the direction u and the value of the directional derivative in parts A and B that make the directional derivative the largest in part A, B directional derivative smallest. And in C, D, and E, we have the directional derivative set equal to a given constant. We learned back in section 14.5 that the maximum value of the directional derivative at a given point is the magnitude of the gradient. And it occurs when the directional derivative has the same direction as the gradient. So what's the gradient? The gradient of this function is the partial derivative with respect to x in the I component, 2x minus y, partial with respect to y in the j component, minus x plus 2y minus 1. Evaluated at our given point, our x naught, y naught, which in our case x naught is 1 and y naught is negative 1. And what we get out is 2 plus 1 for the I component, negative 1 minus 2 minus 1 for the j component. So the directional derivative is 3, negative 4. The gradient is equal to that. And it is the direction, same direction as the direction of maximum value. Now, when they have this u in every one of these problems, although it isn't really stated in the directions, in the way they word the problem, the u that they're searching for is a unit vector in this particular problem. So we have to make this magnitude 1. And so we get 9 plus 16, so we get magnitude is 5. That will answer this question. The maximum value, the biggest the directional derivative could ever get, is equal to 5, and then the unit vector u is 3/5, negative 4/5. Okay. Now part B. Smallest. Well, that's going to be in the opposite direction of the gradient. Now remember, the gradient was 3, negative 4. So opposite the gradient is going to be negative 3, 4. Make it unit. But this number here is negative 5. That's the smallest the directional derivative can ever get at that point. So the u that they want is negative 3/5 and positive 4/5. When you type it in, I think they want it as I and j notation, so do negative 3/5 I plus 4/5 j when you type it in. Okay, great. So now we encounter these last 3 parts, C, D, and E, where we have a prescribed value for our directional derivative. We know it could be 5, we know it could be negative 5. So now we have some numbers between these two values. Well, what can make the directional derivative 0? What can make the directional derivative 4? What can make the directional derivative negative 3? That's what they're asking. Okay, so let's first deal with the directional derivative being equal to 0. What is this symbol? What is the directional derivative of f at 1, -1? It is the gradient at 1, -1 dotted with some vector, generically we'll call it AB, where AB is the direction. We're in search of AB, this vector AB. And this is going to be, in part C, set equal to 0. This vector AB, in this setup of it in the top, they call it U, and so that's to help us out. It's not just any generic vector that's going to make the dot product 0. It is a unit vector. So we, whatever the magnitude is, we got to make it equal to 1. But we know this value from before. The gradient at 1, -1 is 3, -4. So 3, -4 dotted with AB should be 0. That's one equation that you're going to get. Another equation that you're going to have to solve is the fact that it is a unit vector. So a squared plus b squared better be equal to 1. And now it's your job to solve these two equations. What you end up with is two values of, you get two vectors. And when you type them in, be careful to use I and J notation. And when you get them, when you get the two different vectors, A1I and B1J, put a comma before you type in the A2I and the B2J. When you type it in, make it look like this. Okay, I'll let you solve that. What's different about D and E? Well, instead of being set equal to 0, it's set equal to 4. And it's much more difficult to solve when it's set equal to something that's non-zero. See, this guy set equal to 0. You do this dot product and you get a nice substitution for the second part. Okay. So that's for C. And then for D, 3, -4 dotted with A, B, now is set equal to 4. And A squared plus B squared needs to be 1. This is more complicated to solve because the vector isn't 0 here. Substitution is much more difficult. Okay, so let's solve that. And then letter E is the same, but now set equal to